guest speaker for the day, Dr. Axilia Michael ma'am here joining us. Welcome ma'am. So I'll give a brief introduction about ma'am. So ma'am has had 19 years of teaching and learning experience. So ma'am is working in Sri Manakula Vinayagar Engineering College from 2021 to currently. So ma'am has got many publications in the papers, and ma'am has done her PhD in Satyabama Institute of Science and Technology. Ma'am had undergone high performance computing master trainer program, and ma'am is quite interested in programming. Ma'am has got an array of expertise in C, C++, Java, Oracle, and Linux systems also. Then ma'am has got professional membership in IEEE and ISTE as well. So we are happy that you could join us, ma'am. So thank you. So now I would request Goldarjit ma'am to felicitate our speaker for the day.
I'm very happy to, and I'm having immense pleasure to see you all and join you all in this ATAL FDP. And as I am going to start this. Let's have a recap. Any participants have attended the class yesterday, session yesterday? So I think you would have learned what is meant by OpenMP, what is the use of OpenMP, and what is the use of parallel region, how the threads can be spawned, and how to get the number of threads, and how to set the number of threads, and all the basics, how to run a basic OpenMP program, and everything you have got into touch, right? So now we are going to discuss about, we are going to dwell into the concepts of working constructs. Like, can you tell me what is the use of OpenMP? Let's have an interactive session, otherwise.
Thread level programming.
It's a thread level programming. Is it a distributed model, memory model, or shared memory model? It's a shared memory model. Okay. So you have the basics. Let's have a recap. So these are all the things you have come across in the yesterday's class. So we use shared memory model in OpenMP. So we use the concepts of threads. Threads are nothing but a lightweight process, lightweight unit which has its own memory, and it can also use the shared memory. The threads, each individual thread has its own private memory, and it can pass the data through the shared memory also. And the main concept behind this shared memory model is fork and join concept. So as soon as the master thread enters the parallel region, the master thread will divide the threads into multiple threads, and after exiting the parallel region, all the threads will be again joined into a master thread. So this is the basic concept. And if you want to make a thread to enter a parallel region, or if you want to make a master thread into worker threads, then you have to enter a parallel region. For that we use a pragma called as OMP parallel. And we must be sure about how many threads are working in that parallel region. So for that we will be using the inbuilt functions like get thread num and get num threads. Can you tell me, this will be little confusing. Can you explain what is the use of num threads and
thread num will return the thread ID.
ID. What is the ID? Which
particular
thread is currently working, and
number of threads.
Total number of threads that are participating in that parallel region. So with this, yes. Yes, the answer is there only. So now we are going to discuss, since we are having multiple threads in a parallel region, we should distribute the works over the threads, across the threads. So for that we go for a concept called as work sharing concepts. It is used to distribute the works among the threads that are working in a parallel region. So any thread can enter, there is no barrier. So any thread can enter the parallel region, but on exiting, if we use a clause called as barrier or construct called as barrier, then each and every thread should wait until all the threads have completed their work, and after completing all the works of each and every thread only, the threads can exit the barrier or it can exit the parallel region. And you can make it, you can use a clause called as no wait, which makes you not to wait. So there is no barrier. As soon as the thread, if thread 1 completes the job, then it can. Okay. So we have implicit barrier inside the parallel region. If you don't want the implicit barrier, then you can use the clause called as no wait. Let's see in detail. And these are the restrictions. So it must be dynamically enclosed within the parallel region, and it should not you cannot use the threads outside the parallel region. And it should maintain the same order. All the threads should maintain the same order.
What do you mean by the same order? Because yesterday we saw the thread.
Ma'am, I am not telling about the threads, ma'am, about the constructs. You will be using several constructs like parallel, then critical. We have plenty of things, working constructs. So the order should be maintained by all the threads. If we have 5 threads, all these 5 threads should maintain that order. And these are the famous work sharing constructs. So the first work sharing construct is for, and the next one is section, and the third one is single. These are the high level work sharing constructs. So for is used for ensuring data parallelism. Can you tell me what is meant by data parallelism? Any guess?
The same problems being executed.
Any examples?
Array multiplication.
Yes, we will be having loops which handles data repeated in a repeated manner. In those cases, we can use parallel for. And if you want to do some functions in parallel, in such a case that one function should not affect the other, then we go for the construct called as sections. Okay, this is used to achieve function parallelism. And if you want to restrict it for a single statement or single thread, then you can go for C. So these are the working constructs. So as I said, for loop, the construct for is used to achieve data parallelism. So can you guess how it does? In which way? Any guesses? So you have the answer in the picture itself. Anyways, if you use parallel region, we will be using fork and join. Can you imagine how this data parallelism is achieved using for? Iterations. Yes. So each iteration will be divided among the threads. So if you say, for example, if we have 1000 iterations and if we have 5 threads, what happens? Each based upon the number of threads, the iterations will be divided. For that division, we go for this OpenMP for. So as it says, it shares the iteration of loops across the multiple threads. And this is the syntax for using for OMP for parallel for.
What is being followed by that new line for loops? Add no OMP for is that syntax.
Yes.
And then you can give some parameters inside. Followed by
It is not parameter, man. Those
That
are
is
all
that-
classes.
classes.
Classes. Those are not parameters, those are classes. Like whether you want to share the data among the threads or you want to keep it as private, whether it can be scheduled, based upon which criteria you are going to divide the number of iteration across the threads. So those will be specified in the class section, and within that you can use for loop. Within the pragma for, you have to use for loops. And these are the some of the classes which would be used in the for construct. So first one is private, first private, last private, shared, and reduction, schedule, and no. We have plenty, but we will be using these often. And some restrictions are, you should not use do while. You should use only for. You should use only for. In case of Fortran, you can use do loop. In case of C, you have to use only for loop, and that too, it should have the same iteration. Increment should be same for each and every iteration. It should not vary. And if you backtrack your program backwards, then this should not be used. So say for example, we'll be having some situations in which we use I minus 1. So it means we will be going backwards. So in that case, we cannot use this OMP for.
Do you have a special construct for that, or we cannot do that at all?
We cannot do that at all. And it is illegal to, you cannot use the unconditional branch like go to and all inside the for loop. And let's discuss the first important clause, that is schedule. So this determines how the iterations are divided among the threads in the form of chunks. So imagine that we have 1000 iterations and 4 OMP threads, and the loop is partitioned as follows. So the basic thing we will be using is number of iterations divided by number of. So here the number of iterations is 1000 and number of OMP threads is 4. So based upon that, 1 to 250 will be managed by, the chunk will be managed by thread 1, the rest will be managed by the subsequent threads. And we have many clauses for this schedule. We have 5. One is static, then the next one is dynamic, third one is runtime, and guided, and auto. So these are the 5. Let's see it one by one. So here, based upon the chunk size, if you specify chunk size, it will divide like this. If you have 26 iterations and we have 4 processors and the chunk size is 6, then it will divide like this. So So the first 4 threads. So we have different threads like thread 1. Olive green gives you indicates thread 1 and pink indicates thread 2 and thread 3 and thread 4. The remaining 2 will be allotted based upon the system requirement. The thing will be allocated. So this is regarding static. And regarding dynamic, the size will be default chunk size will be 1. Default chunk size is 1. If you specify, unless otherwise you specify the chunk size, the default size is. So since we have given the chunk size again as 6, the string will be the same. Otherwise, if you don't give chunk size as 6, then and this is guided work sharing construct. So the threads will start decreasing. So at first it will allocate the maximum chunk size. Then after subsequent iterations, based upon the remaining number of iterations and threads, the allocation of chunk size will vary. See here. So here the size is 4 and the type is guided, and we have 4 processes. So the first thing we have allocated all the 4 iterations to each and every thread, and after that it starts getting reduced based upon the remaining number of iterations and number of threads. This will vary and it will stop when you reach chunk size of. Until then the division will happen based upon the number of remaining iterations and number of. So this is what happens there. So in the first, initially it will use number of iterations by number of threads, and as the time goes, after the first iteration or after the allocation of fixed chunk size, then after that it will allocate subsequent blocks to proportional to number of iterations remaining by number of threads. Here also, if you don't give any chunk parameter, the default sizes, and all this guided and the previous thing, dynamic will use first come first serve basis. Whichever thread comes first, it will allocate the chunk size. The order of getting the chunk size may vary. Number will not differ, but which the thread, as you said, the system will decide which thread is going to handle that iteration.
Differentiate dynamic and guided, the same example that you have used for guided.
See here, ma'am. Here, constantly after allocating 6.
If you take the previous example,
Yes.
that chunk size is 4, so 4 will be
Yes.
allocated
Yes.
and 10 will be remaining.
Yes.
Again 10 when divided by 4, 2 will be allocated
Yes.
and 2 will be remaining. The 2 will be allocated to one of 2 threads, even in dynamic, right?
Yes,
The
yes.
same thing was what happening in the guided as well.
No, in guided, as soon, once it gets to 2, then it will become 0 or 1. Right? So after that, only one iteration will be allocated to that each. Here the remaining process in dynamic, the entire remaining threads will be, or iterations will be handed over to any one of the threads. Either to thread 1 or thread 2 or thread 3. See here. So here we have individual allocation for each and every, unique allocation for threads, and here the allocation is.
Do we need to mention in the program itself,
Yes, yes,
scheduled
sir.
or guide?
Yes, sir.
Or you have a separate schedule?
No,
We need to-
while
everything-
using the for itself,
Everything you need to mention.
everything you should. So that's why they have it. Even
Yeah.
if you don't
Actually-
give that, even if you don't give that, it will take the chunk size as 1.
Default.
Default. Chunk size is, unless otherwise you specify chunk size, the default size is 1. You can try it.
Default type is
Default type is the first one, static. And you can use it, you can defer this allocation of chunks until runtime and based upon the thing called as OMP schedule or OMP underscore set underscore schedule. You can set the type of the schedule. And if you give the choice, if you want to give the choice to the compiler, then you can use out. So you cannot use a do while loop for this using this pragma for, and the iteration count should not program correctness should not be dependent upon the thread execution, because you already know that the thread will execute in different order based upon the schedule given by the system. So operating system. So we cannot predict the correctness of the program based upon the threads. If you want, you can try this program. If you have your login, you can try this program.
We can switch on any of the systems similar to the same. You have to just open the same mobile system.
do you have any open compiler for this open like program?
There is one, but it's not.
But it is not giving correct.
Why we don't have?
Actually, sir, this is for handling huge amount of data. So the supercomputers only will be using this. So yes, we can use for data analysis and applying the machine learning algorithms, but still. See, if you want to experience, just a minute. So if you want to experience how this schedule, type of schedule works, static, dynamic and guided, you can use another for loop. Since for simplicity I have printed the last element of C array. Okay, you can use another for loop and you can print and see how the chunk size is getting allocated.
Why there is no open and closed spaces after the second diagonal inside diagonal?
So this is to differentiate that these comes under serial code and this comes under parallel code. But inside the it's not included even in the syntax. This is the syntax.
If you don't put that, then only the first line will be only considered for this. Because that is what
This
usually
for
see.
this for schedule is used to enclose the for loops. So as long as the for loop is over, it will be
You don't need to.
no need to specify. It has scope till the for loop ends.
number and yes, 103, but 102.
Those are user-defined variables. You can use on your own. No need to do as such. Types of schedule, dynamics, then you include a for outside, ensures the structure inside of like. You don't use Vim editor. Hash include STD IO.H add பண்ணிக்கோங்க. மண்ணெல்லாம் இருக்கிற கொண்டே மாதிரி மேலே கீழே எஸ்கேப் ஆயிட்டுங்க. எஸ்கேப் ஆயிட்டு எந்த பாலிசி
Same for this one. இல்லை மேம் ரிசர்ச்
after that
மேம் முடிச்சுவாங்க
சொல்லுங்க
சொல்லுங்களேன் ப்ரோக்ராம் அப்படியே அந்த டைனமிக்
அதுதான் சார் இப்போ வந்து இது எப்படி ரிவைட் பண்ணுறதுனா நம்ம எக்ஸாம்
good idea.
நம்மளோட ரெஃபரன்ஸ் தான். நீங்கள் உங்களுக்கு இல்லை சொல்கிறேன், உங்களோட ரிசர்ச் ஒர்க்கு இது உங்களுக்கு ரொம்ப யூஸ்ஃபுல்லாக இருக்கும். மாடலிங் எல்லாமே மாடல் பில்டிங் எல்லாமே இதில் வந்து இந்த மாதிரி இருக்கும். ஆனால் இது வந்து யங் சைஸ் வேறு வரும். நீங்கள் நோ வெயிட் கொடுத்துட்டாங்க, அது அப்படி வந்துட்டு நாலு த்ரெட்டு வந்து மட்டும்தான் சரியில்லைங்க. ஸோ அதை வெளியில் கொடுத்தாதான் சி வந்து அந்த அரே நேம் சார், அரேவோட வேல்யூ லாஸ்ட் வேல்யூ மட்டும் பிரிண்ட் பண்ணுறாங்க. போட முடியாது. நீங்கள் இந்த ஃபார் ஷெட்யூலில் ஐடியும் ஃபில் பண்ணீங்க, சிஎஃப்ஐ அந்த மாதிரி பண்ணாலும் ஐடி பண்ணீங்க. அதுக்கப்புறம் இந்த வெரி ஃபார்மோட நீங்கள் ரிலீஸ் பண்ணிட்டீங்க. See here, the chunk size is 6, right? So 1, 2, 3, 4, 5, 6. And chunks for the next thread, the chunk size is 6. So 4, 6 chunks will be allocated, and remaining 2 will be allocated for the other thread. You are asking this one, huh?
But I'm not getting the output like this.
Even the exported the processor number of threads again.
Once you create and then stay like that.
Since we have more than one station in the last in the example given, I have used only no statement inside the so I didn't use this open parenthesis and used but here we have used two lines, no?
That is enough use for paragraph.
For forward. Yes, they are given in the same program that is so you can learn after getting used with this programming, you can easily learn all the other practice. Just scroll it. This is splitting the silk and this is shall we move on to the next pragma? We are running out of time, Mark. We have lot of pragmas. See, you can try this program with the different schedules. Like we have seen the example with dynamics. You can try it with guided, and you can try with static also. See, I will be sharing all the PPTs with you, so you can be in touch. And the next, please, participants. Ma'am, excuse me. So the next pragma is section pragma. So which is used to achieve functional parallelism, so that more than one section and more than one thread can do different jobs simultaneously. So this is the concept behind sections. And this is the syntax for using sections. The outer sections define that we are entering into the sections pragma, and you have to define if you want to divide your code into, if you want to execute two functions by two threads simultaneously, then you can use two sections. If you want to include 4 sections, you can use 4 section pragma inside the sections pragma. So this is
Each section will have its own thread.
yes. Then and those threads.
Define different number of threads for different number of sections. Like first section 2 threads, second section 4 threads.
No.
The other threads has to be the same.
And try this example. See here, just observe. So we have used 2 sections here inside the sections pragma. One will do vector addition and the other one will do vector multiplication. Both these functions will be done parallelly by different threads. One result of one thread will not affect the other thread. So that is the use of sections pragma, which is used to achieve functional parallelism. You can try this. Can we try all these programs in the afternoon session? Huh? That's better, na? So, and the next section is, and the next construct is,
Yesterday we learned all this concept, but we didn't get time to do the program.
they have taught all these things.
Yes.
All
Only
the
we were not
practice.
able to do the program because of lack of time. So I don't know others, but I prefer to have the programming experience rather than having the sections, restrictions, all have been set up yesterday.
Okay.
We have shown an example program, but we didn't get the time to execute.
Okay, then you can proceed. Then you can have hands-on something. Please be quick as we are running out of time. See, one section performs vector addition and the other one performs vector multiplication. Other programs are all very simple programs only. Only this program will be lengthy.
We are not using chunk size here.
No, not necessarily it's needed for
That
this
is one.
specific. Yes, its default value is 1. We didn't specify the schedule value also here. So it automatically considers it as static. Don't miss to include stdio.h. ஒரு பிக் எடுத்துக்கிட்டீங்கன்னா அழகா பார்த்து டைப் பண்ணிடலாம். தலையை திருப்பி திருப்பி பண்ண வேண்டிய அவசியம் இருக்காது. It's a random value. You can give 0.5 also. That's your part. இருக்கக்கூடாதுன்னு ஒர்க் ஆகாது. Yeah, 5% float in the video. Percentage.
Even me, I just copy that and when you connect it is up. Okay. It's not control, it's shift is
This is the first time I'm hearing. I know. Dot slash section. Slash section. And since you have not changed here.
Coming as C.
வரலையா? டேரக்டர் நேஷனல் அலைனா நமக்கு டேரக்டர் தான்.
இப்போ இந்த மாதிரி அப்ராக்சிமேட்டாக ஹவு மச்
இப்போ வந்து பார்த்தீங்கன்னா ஒர்க் ஷேரிங் கான்செப்ட்ஸ், சிங்க்ரனைசேஷன் கான்செப்ட்ஸ், என்னென்னலாம் இருக்கோ அது எல்லாமே ட்ராக்மால டாக்ஸு, செமஃபோர்ஸு, அது மாதிரி டைரெக்டாக இல்லாமல் சீக்ரெட்ஸில் அதெல்லாம் நம்ம என்ன பண்ணுவோம் ஓஎஸில் இங்கே வந்து நம்ம கிரிட்டிக்கல் செக்ஷன் பேரியர் இதெல்லாம் அட்டாமிக் ஃபோர்ட்ரான் பைத்தானே ஓப்பன் எம்ப்ளி பைத்தன் ஓப்பன் எம்ப்ளி பைத்தன் இது எம்பிஏ பார்த்தீங்கன்னா பைத்தன் எம்பிஏ பைத்தன் ஆமாம் மோஸ்ட்லி ஏன்னா வந்து பைத்தனுக்கு ஓப்பன் சோர்ஸ் அதனால எங்களுக்கு ட்ரெயின் பண்ணும்போது மாஸ்டர் ட்ரெயினராக நாங்கள் அட்டன் பண்ணும்போது இது ஃபுல்லாகவே இது வந்து நீங்கள் இப்போ ஒரு நாளில் படிக்கிறீங்க இல்லையா நாங்கள் 3 days ஓப்பன் எம்ப்ளாய்மெண்ட் அதில் டாஸ்க்கு அதெல்லாம் இப்போ அது வந்து ஒரே நாளில் 2 months இப்போ நான் பிளான் பண்ணி வரது இப்போ 2 பிளாட்ஃபார்ம் வந்து ஒரு 12 அதெல்லாம் டெப்த் நீங்கள் வந்து உங்கள் ரியல் டைம் அப்ளிகேஷன்ஸ் பொறுத்து இது எல்லாமே மாறும். இது நீங்கள் 1000 தான் முடிஞ்சிருக்கீங்க. இப்போ நீங்கள் ஏஎன்எம்எல் போறீங்கன்னு அப்போது நீங்கள் வந்து டேட்டா செட் எவ்வளோ இருக்குதோ அப்போது இது ரொம்ப நல்ல எஃபெக்டிவாக இருக்கும். ஸ்மால் ரேஞ்ச் இருக்கும்போது பேரலைசேஷன் வந்து ஓவர் ஹெட்டாக தான் இருக்கும். லார்ஜர் சைஸ் தான் பேரலைசேஷன் உங்களுக்கு ஓவர் ஹெட்டாக இருக்காது. அந்த ஆஸ்பெக்ட் வந்து நம்ம அவங்க எஸ்டிஎம் இதெல்லாம் பண்ணும்போது நீங்கள் வந்து ஒரு ப்ராப்ளம்னா மாடல்ஸ் யூஸ் பண்ணும்போது இதில் வந்து உங்களுக்கு இன்னும் சூப்பராக பண்ணோம்னா நம்ம மேக்ஸிமம் யூட்டிலைசேஷன் எடுத்துக்கணும். இமேஜ் நம்ம சிஎன்என் அந்த மாதிரி அதுலலாம் இது வேறு லெவலில் ஒர்க் பண்ணும். இப்போ நீங்கள் ஒரு எஃபோர்ட் நீங்கள் வந்து நார்மல் சிஸ்டமில் ஒர்க் போகும்போதும் முடிஞ்சு நம்ம வந்து கொஞ்சம் டேட்டா செட் எடுத்தாலே அதனால தான் அப்போ உங்களுக்கு பேரலைசேஷன் ஃபாஸ்ட்டாக உங்களுக்கு இதெல்லாம் நாங்கள் கிடச்சோம் இல்லை சூப்பர் கம்ப்யூட்டர் ஆமாம் இப்போ நான் வச்சுருக்கோம் என்னோட சூப்பர் கம்ப்யூட்டர் மரலோட கஷ்டம் உங்களுக்குமே அதுதான் பட் இந்த நேம் சார் நீங்கள் யோசனை நாங்கள் பெங்களூரில் அட்டென்ட் பண்ணதுக்கு எங்களுக்கு 1 year கொடுத்துருக்காங்க. அதெல்லாம் நாங்கள் யூஸ் பண்ணியிருக்கோம். எல்லாமே மானிட்டரி பெனிஃபிட்லாம் பண்ணுறோம். பெங்களூரில் இப்போ நாங்கள் ஃபெப்ரவரி நாங்கள் அட்டென்ட் பண்ணோம். ஃபெப்ரவரியிலேருந்து நெக்ஸ்ட் ஃபெப்ரவரி அது இனிமேல் தான் நான் பெங்களூரில் மேம் அது ஓப்பனாகவே காலேஜஸ் சப்போஸ் எனக்கு வந்துச்சுன்னா நீங்கள் உங்களோட மெயில் ஐடி கொடுங்க. நான் எனக்கு வந்துச்சுன்னா நான் உங்களுக்கு ஃபார்வர்ட் பண்ணாமல் நான் ரிமைண்ட் ப்ராப்ளம் இல்லை அதுதான் இது ஒன்ஸ் இன் இது ட்வைஸ் அந்த மாதிரி இப்போ பார்த்தீங்கன்னா ட்வைஸ் கண்டக்ட் பண்ணுவோம். இப்போ இங்கே சென்னையில் சீரக் இருக்குது ஆனால் என்ன பண்ண மாட்டேங்கிறாங்க. மட்டும் போதும் ராஜ வாழ்க்கை 15 days ஓப்பன் அப்பதான் ஓகே ஆமா ஆக்சுவலா நீங்க பாத்தீங்கன்னா 2.5 என்னால் இன்னும் 2 செட்டு கூட என்னால் முடிக்க முடியல. அவங்க என்ன பண்ணுவாங்கன்னா 6 7 வரைக்கும் உட்காந்துருக்காங்க. ப்ரோக்ராம்ஸ் எல்லாமே பண்ணுறீங்க பாருங்கள் எல்லாமே செக்யூரிட்டி ஆஸ்பெக்டில் ஏதாச்சும் செக்யூரிட்டி ஆஸ்பெக்ட்னா பேசிக் தான் அது அவங்க எப்படின்னா இந்த மானிட்டரி இதெல்லாம் பண்ணுறாங்க எப்படின்னா இப்போ வந்து எங்களுக்கு இதோட ஆர்வம் எங்களுக்கு வந்துச்சு அப்பா அவங்க வந்து அதுக்கான செஷனே இருக்கு கூடாது எங்களுக்கு பார்த்தீங்கன்னா வந்து நாங்கள் பண்ண முடியாது
எப்படி போகணும் தெரியல. நம்ம கேமரா கிராஸ் பண்ணிட்டு இதில் உட்கார ஒரு ஓகே கீழே இன்னும் கொஞ்சம்
MP அது பெட்டரா இருக்கும்னு நினைக்கிறேன் பார்த்து பார்த்து பண்றதுக்கு நான் இப்போ ரஷ்அப் பண்ணிட்டு நம்ம போயிடும் மதியம் அவங்க டீச்சரை வச்சு அவங்க பண்ணிட்டாங்க ஒரு எத்தனை நிமிஷம் டைம் இருக்கா 4:30 அப்போனா இது பெஸ்ட்டுன்னு நினைக்கிறேன் அவங்களே கேட்டுருவோம் பண்ணிடுவோம் அப்படின்னு நாளைக்கு தேதி எடுத்து எல்லாம் நேற்றே ஷேர் பண்ணிடுவோம் அவங்க பேரலாக நான் இப்போ வந்து கான்செப்ட்ஸை விட்டு ரஷ்அப் பண்ணிருக்கேன் மதியம் போயிட்டேன்னா ஹேண்ட்ஸ் ஆனால் அவங்களுக்கு கூட நான் வந்து ஏதாவது ஹெல்ப் எங்களுக்கு எல்லாமே முடிச்சிட்டாங்க அதான் ப்ரோக்ராம்ஸ் போட, அதாவது நாங்கள் இப்போ ப்ரோக்ராம்ஸே பண்ணுறோம். முடிச்சுட்டாங்க அப்படின்னாங்க. எனக்கு சொல்லுங்க. ஃபுல்லாக தியரி எல்லாம் போச்சு அப்படின்னாங்க. Participants, please. Shall we move on to the next concept? I think
So this
few of you
PPT
have.
I will share it in the GCR so that you can copy and you can practice. Yesterday also I shared.
Okay, the next work sharing construct is single. Okay, so in this, among several threads, only one will task, others will not do that task. Okay, so only one thread will enter the parallel region and it will update some value. What are all the job you are given to that thread that will be performing, and after that, the other threads will perform. So if only one thread will perform that option. If you give single, only one thread will perform the not iteration, the given task. If it is for if you come across this, if you come out of this single pragma, then then all the threads will start executing. So if you give this construct, only one thread will perform the operation specified in that construct. Afterwards, all the threads will be performing parallel. இங்கே எங்க யூஸ் பண்ணலாம் அப்படின்னா, if you want to do IO operations, if you don't want to get interrupted, then you can use this. So see here, you can see the difference between the diagrams here. So in for, the for loop will be shared by all the threads. Iterations will be shared. In section, each thread will have its own function. Thread 1 is lightly loaded, thread 2 is heavily loaded, and thread 3 is loaded than thread 2. So one operation of one thread will not affect the other. So in this way you can achieve functional parallelism. As you have seen in the example, you can perform vector addition as well as multiplication parallel, okay, without affecting the result of the other. So here, among the threads, only one will do the job, other will not do that particular. So that is the difference between for, then sections and single. And this is the syntax. The same thing, and you have to give the task to be done inside the single. Yes. You cannot decide. The processor will decide. And this is the example. See here, I have enclosed these 3 lines or 4 lines inside this single thread. Only one thread will be performing all these operations. Others will not do this operation.
You are not sharing this, so will this value be available only to the thread?
That single thread, not to the others. Those values is available only to that single thread, not to the others. You can try this in the afternoon session. And as you all know, and non-programmers, you can consider this example. If you are trying, consider there are 2 threads and both the threads are trying to increment the value of x by 1. So initially the value of x, imagine that the initial value of x is 0. So both the threads will assign 0 to x. Then it will try to increment the value by 1. But what happens here? What will be the output of this code? If consider this as the code, this code is executed by 2 threads parallelly. Same variable is used by both the threads. What will be the output? called as, in this situation, race condition occurs. So in one way or the other, one thread will be reading the values before getting written by the other thread. So this is called as race condition. Instead of getting 2, we will be getting, okay. So that is called as race condition. In order to avoid the race conditions, we should have some high level synchronization constructs, and those are called as critical, barrier and atomic. So as the name implies, if you want to make your thread to enter into a critical section, only one thread can handle that, can enter into the critical section at a time. If both the threads are contending, if any one thread is trying to enter while the other thread is inside the critical section, it has to wait. The one which is trying to enter the critical section has to wait, say it for thread 2, and the one which is inside the critical section is thread 1. Thread 2 will have to wait for thread 1 to come out of the critical section. And this is the syntax.
Can't use it single instead of synchronous because it does the same job. No preventing.
No ma'am, here we have all the threads, but task is given only to single thread. Here every thread can contend to operate that particular value, access that particular value. So in that case, only one, if you want to allow only one thread to access the data, then you have to use the section called as critical section. So this will avoid race condition. And the next one is atomic. So this you can use for more than one statement. If you want to make a single statement to be considered as a critical section inside the critical section, then you can use the atomic constraint. So atomic means single. So only inside this atomic section you can give only one statement, not more than one. So this is a mini critical section.
This is automatically will take or?
We have to specify something.
No, if you give atomic, only one thread can be.
Every thread can access, but it can synchronize only one statement, not others. Only one thread can access that single
In this
statement.
case, atomic case, thread 2 has to be wait.
Wait till that statement gets executed.
What is the difference between atomic and?
So that's what I am saying, sir. If in critical section you can place more than one statement. So the thread can execute 3 statements inside a critical section. If you give it as atomic, only one statement can be executed by a single thread at a time. And the next one is barrier. So as I said, if we have 5 threads, imagine the 2 threads have completed. Okay, it cannot come out of the section. It has to wait till 3rd thread, 4th thread and 5th thread gets finished. Then only it can get out of the section. Barrier section. It has to wait for the others to complete. So this is useful when you want to maintain the ordering of some instruction, and if you want to get correct results, then you can go for barrier. And this is the syntax.
But you say default is barrier.
No, it's not like that. Barrier, even if you don't specify barrier, the parallel pragma will invoke this barrier constraint. If you don't specify. If you want to, we have 2 types of barrier, implicit barrier and explicit barrier. So this comes under, if you specify hash pragma OMP barrier, then it comes under explicit. You are explicitly forcing the threads to wait. And the pragmas like parallel, for and single will have default barriers. Even if you don't specify barrier, all the threads will wait for the other threads to finish. That's what I meant to say. you execute this thing, you can understand what is the use of barrier and without barrier. You can use, if you want to make only one thread to enter the barrier, not all the others, then you can use one construct. What is that? Only one thread should enter the barrier, not the others. Single. So in that case, you can use single. In the thread அதை access பண்ணுமோ அதை மட்டும் நீங்க single. And this is the pictorial representation of barrier, working of barrier. So imagine that we have 4 threads. 2 threads have completed, so it should not exceed the barrier section. Thread 1 and 2 should not, 0 and 1 should not exit the barrier section. It should wait until thread 2 and 3 reaches the barrier point, barrier point. After that only all the 4 threads can exit. And these are the data environment variables. So you can make a variable as like access modifiers. You can use public, private and protected. Likewise here we can use clauses like private, first private, last private, then shared, default, reduction and copy in, copy private, like that. We have plenty of data environment variables, you can use it. So if you want to maintain some values or values of a variables only to a particular thread, or each thread has its own value, private value, then you can go for the thing called as private. Okay. So if once you give the class as private, environment variable as private, then it will be, the scope will be within that pragma only, not out of the pragma. It will be, for example, if I use hash pragma OMP parallel private x. So that private of x, that variable x will be available only within the parallel region. Outside the parallel region, it won't be having that value. So you can't see the value of x, any updation of x outside the parallel region. And the next one is shared. A variable can be shared by all the threads. So if you should be very careful. If you declare a variable as shared, then you should ensure that race condition does not occur. Either you have to use critical section or barrier or end. All the synchronization, any one of the synchronization can be used. Better it is useful if you, it will be fruitful if you use critical section, because it handles multiple statements, whereas atomic handles only one statement. And barrier is used only for maintaining the correct order and correct results, not more than that.
If atomic is handling only one thread at a time, why can't we go for single?
She also asked that question, ma'am. The answer is single. See, single is nothing but you have 5 threads. Imagine that you have 5 threads. If you want to make sure that only one thread executes some set of statements, then you can make it as single. Not other threads will handle those statements. But atomic is used to handle only one statement, not one thread. All threads can access that atomic region, but one statement at a time. So in private there will not be any initialization, whereas in first private we can initialize. Okay, we can initialize the values that will span across the threads. And last private is, here the value of the last iteration will be considered. Whatever may be the value, you might have given as last private of x is equal to 3. So if you have iterations like 5 iterations, it will print the last iteration value as the risk. So that is the use of last private. And we have one more option that is called as thread private. So you can ask, what is the difference between private and thread private? So here private cannot be used inside functions or blocks. It can be used only inside the threads. Whereas thread private can have global even functions and threads, and all the private values will be made available for all the threads in the class. Copy of that private value will be shared among the threads. Whereas if you use private, that is not the case. It will have only local scope. So it is not persistent. It has private has only local scope, whereas this is persistent across the threads. So if you want to use thread private, then you have to use copy. Then only the values will be delegated from master thread through the worker threads. Otherwise, it will not be copied. So if you use copy in only, you can use thread private. So like that, copy private is associated with a single directive. So only one thread can access that private value, that is copy value. See, the master thread will broadcast the thing, that is private value, to the single thread that is entering into the single section, not for the others. And the last important OpenMP concept is reduction. So if you want to maintain a copy of your local values, say for example, if I want to find the sum of n numbers, let the numbers be 1000. If I want to find the sum of 1000 natural numbers, then I have to, if I want to maintain the local copies which will not be affected by the other threads. If you use parallelism, then multiple threads will be using those iterations and result. So if you want your values or local copies do not be affected by the other threads, then you can use this reduction. So each thread has its own local copy, and after some stage, it will start reducing the values into a single value. So let me explain this.
But anyway, the thread has some local variable that cannot be accessed by other threads, right?
Yes, ma'am. That is, ma'am. If you didn't give private, then what will be the case?
No, the local copy of the thread I'm talking about. That copy, that variable can be accessed by all the threads, but if you have a local copy for the thread, that cannot be accessed by the other threads. That's what I understand.
Ma'am, actually, if same, see, all the array names will be shared by all the threads, right? So one thread can handle or update the value of 0th location. The other thread will be updating the value of ith location, and like so. If you use guided, yes, if you use dynamic, same set of threads will be allocated the chunks. So same set of threads will be updating the values again and again. You won't get the result correctly. So in that case, if you want to maintain the local copies, then you can go for this sum. So here the reduction symbol is plus, which indicates that it is going to sum the values, local copies of the values. So imagine that this is the addition step, and each thread will maintain the local copies of, so if you have 15 array locations means, then 0 and 1 will be allocated to thread 1. Likewise, it will maintain the local copies of the values, local copies, and after that it will find the sum, and the sum will also be maintained as a local copy, and after that plus reduction will be big. So, and at the last you will be getting the correct answer. So just if you don't use this reduction operator, you just write simply using OMP pragma parallel and tell me what is happening and what result you are getting. Then only if you do hands-on only you can understand what is the use of reduction and what is the, if you don't use reduction, what will be the risk. So if you don't use this reduction, then you can have multiple values for each and every run. For first time you can get 704. For the second time you can get any local values, 337. Like
You mean the last sum value will be no different values? The last sum. Sum is equal
see
to
here,
sum.
ma'am, each thread has its own sum, local sum. That will be combined into a global sum. So we need global sum only, not the local sum. If you don't give this reduction, you will be getting local sum values. You can try it without this reduction also. So that's all about just about OpenMP. We have plenty, but due to stipulated time restriction, I could cover all these things. While doing hands-on, you can ask me questions. Okay? Without, because you will be very confused among how to use private and loss private. Ma'am, what is the difference between loss private? Even if I tell no, you won't be able to understand. If you have hands-on, you can understand it easily. Even if you have doubts after hands-on, then I will help.
Give us the program.
I will call. With your permission, can I finish MPI theory also? We have one time till 1 o'clock. நம்ம இதெல்லாம் பார்க்கவே வேண்டாம் மேம். ஏசிடில இருந்து நம்ம கன்ஃபார்ம் சீடை கன்ஃபார்ம் பண்ணாங்க நமக்கு. இது வந்து எப்படின்னா நான் சொன்னேன் இல்லையா, அகாடமிக் இப்போ வந்து உங்களுக்கு இந்த டூல் யூஸ் பண்ணணுமா, டிப்ளமா கோர்ஸ் பண்ணணுமா, இப்போ யூஜி முடிச்சுட்டு வேலை இல்லாமல் இருக்கீங்களா, என்கிட்ட வாங்க, பிஜி கோர்ஸ் இருக்குது, உங்களுக்கு இது பிளேஸ்மெண்ட் கிடைக்கும், கொடுப்போம். ட்ரைனிங் ஆஃபர் பண்ணுறாங்கன்னா அதெல்லாம் தான் இதில் இருக்கும். அதுதான் இதில் இருக்குது. பிஜி டிப்ளமா கோர்ஸஸ் என்னென்ன இருக்குன்னு வரும், என்னென்ன ட்ரைனிங் ப்ரோக்ராம்ஸ் இருக்குன்னு வரும், ஐஓடியில் ட்ரெயின் பண்ணுவாங்க, அது வராது இல்லை. ஏன்னா அது ஏசிடி அலாங் வித் சீடர்.
So ACT code
எங்களுக்கு ஏசிடி தான் வந்து லிங்க் பண்ணுறோம், சீடர் கணக்கு. இப்போ ஒன்ஸ் நீங்கள் வந்து மாஸ்டர் ட்ரெயினர் ஆகிட்டீங்கன்னா சீடருக்கும் அனுப்புவாங்க. எங்கள் டேட்டா அவங்ககிட்ட இருக்குங்க. எங்களுக்கு ஃபெப்ரவரியில் நடந்தது, மேம்க்கு ஜூனில் நடந்தது.
You would like to attend when it comes, I will use that. We are in the cedar group, so they want to
That's based upon their
MOU. So we can expect sometime
twice in a year. We will
we
inquire and then they didn't tell us that they are going to
We are going
conduct another training program in a couple of months. They didn't tell us.
You can directly ask that. If they don't know, you can find out. See that.
Yes, ma'am. They have Pura ANM also. So, ANM.
But here I am not sure whether I have been checking or not. This is mostly related to grid cloud computing. We can find what they're going on, whether they are working on it. Value they are working on. What they do is they are working on something like tax.
Ethical habits.
Image processing. Suppose there is a camera which is taking our face recognition. There is some change in the background that is not recognized properly. So it is more like they say that it is some noise will be there. You can correct the image. You will not be able to see that actually. By seeing the image, it will, for a naked eye, it will look like proper text. But actually it is not the case. Since Gaussian noise is already mixed, so it is kind of an attack of that. So they were talking about different kinds of attacks.
The article summary goes to we are Day3, Dr. Karthik and Dinesh Babu and myself, Gautaman. We named as our team Super Brains. And the title, the survey of compute nodes with 100 flip-flops and beyond for supercomputer. That paper gives all this basic information and different supercomputers information in the 100 flip-flops. So it's journal source from CCF transaction and high performance computing and all this other details. So the key method is given. The different key methods from the article. The first one is benchmarking and performance metric. So from that journal paper, it takes the covers various benchmarking techniques used to measure the performance of computing nodes. Different LinPack, floating point operations and custom benchmark specific to different applications. How it given the benchmark and performance metrics as given. And second one is architectural innovations. So it covers with the explores different architectural design that enable compute nodes to achieve high performance. So we are all talking about high performance. So this architecture gives the more innovation about the architectural design using achieving the high performance. And third one is thermal and power management strategies. It also gives the article methods managing the thermal output and power consumption of high performance nodes for the third strategy. And fourth is interconnect and network technologies. It gives focus on the interconnect technologies and facilitate the high speed communication between computer nodes. So for the networking domain, so it uses the technologies with the interconnect and network topologies. So this analysis network of topologies and high bandwidth interconnect like InfiniBand and high speed Ethernet and innovations that reduce the latency and increase the data transfer rates. So we are also always talking about data transfer rates and other minimizing the latency, all those things. So that it covers the interconnect for the network technologies. So next one is kind of architecture analysis and innovation. So this gives the high performance of micro architectures, the pipeline optimization, cache hierarchy improvements, and parallel processing enhancements. So all these topics we are studying now. So these concepts are given as architectural analysis and how that innovation comes with the all these topics with that paper. A domain-specific architecture, it gives the customer instruction set and acceleration integration. And then next one is interconnect technology. So chiplet technology, modular chip design and interchip connection. And advanced interconnects is optical interconnects and then high-speed buses. So it talks about all this various different technologies in the paper with the interconnect technology of networking domain. And the last one is accelerated and specialized processing network. It gives the next generation accelerators and gives the GPU and TPU integration, and customer accelerators, all those things. So this domain specific as well, specific accelerator, ASIC design, and FPGA utilization adheres. The last one is energy efficiency, power management technique, the dynamic voltage and frequency scaling, DVFS. It uses the adjust power usage and performance based on workload. And efficient cooling solutions also, we implement advanced cooling methods like liquid cooling or immersion cooling to manage heat dissipation. Also, this gives the memory optimization. It talks about memory optimization, efficient use of memory access, and high bandwidth memory. So how it access with the memory optimization techniques, reduces and all this. So the next one is advanced packaging technology with the integration, 3D integration and heterogeneous packaging details. So future proofing is in scalability. So the paper gives the scalability planning and modular design for the different applications, modular system design and backward compatibility and flexible architecture and upgrade paths for this future proofing and scalability for this application.
So I'm Dr. Karthik. So as far as my research is concerned, I would like to accelerate the deep learning algorithms, especially in FPGA. So I have taken up this Intel 1 API and trying to run the deep learning algorithm in both GPUs, CPUs, and even in FPGAs. Now, when I enrolled for this ATAL FTP, I got a different perspective. Why can't I have a supercomputer along with hardware accelerators like FPGAs? So I have just gone through few papers and I've gone through this paper, and this paper has given me a lot of innovations like heterogeneous computing, that is mapping of very slow running process in GPUs or in CPUs, and slow running in FPGAs and the faster in GPUs and TPUs. So I just gone through this article. Article is providing a lot of information, and my colleague Mr. Dinesh Babu is doing in stochastic computing. So let us talk about stochastic computing.
Good afternoon all. My research basically focuses on implementation of deep learning systems using a stochastic computing, which is a counterpart of binary computing. So what the challenges here with terms of stochastic is, though it is going to produce accurate results when compared to binary, implementation challenges as usual what we face with the VLSI implementation, the area, power, especially delay. But when it comes to delay or speed up of the circuit, just as I told, acceleration will provide us some good results when it comes to stochastic. But when it comes to again area and power dissipation, it's a main challenge over there. So from this paper I could see there the various thermal effects, and also how to have this management power aware solutions when it comes to implementation of deep learning systems. So hope I'll take some basic concepts over there from this to overcome such problems which I face with my research.
The third one is, this is my actually my research is cheetah-chase algorithm, the shortest path algorithm to give this optimization. I am comparing with traditional algorithm as well as bio-inspired algorithm. So my motivation came with the ant colony algorithm. First start with the ant colony algorithm and bat algorithm and other algorithms. So why can't we go with, at the time the cheetah was not there, cheetah algorithm was not there. So I developed my cheetah algorithm and put around 12 papers in journals and different applications. All this optimization concept and shortest path. So it gives more of optimization. This journal paper gives me the idea of kind of optimization technique, how to improve all this shortest path concept to the paper. So I took that part from this paper. It helps me to cover those optimization techniques. So, kind of takeaways. these are the things. So all this three of us research and other things will be the takeaways from the those single paper.
So a lot of challenges with respect to cost and sustainability concerns. So if that being addressed, I think this particular HPC, I think it paves ways to all kind of research. Thank you. Thank you.
Thank you.
Thank you.
Stop.